In this example, we want to take what we've been learning about standard deviation and apply it to a situation where the data has already been organized into groups, or we've been given a frequency table for how often things occur. So let's just look at this through an example. The Nurses Union collects data on the hours worked by operating room nurses at the Staatsville General Hospital. We want to determine the mean and the standard deviation of this data. We've got the data collected in a table here. So we've got number of hours per week in one column and the number of employees who worked that number of hours per week in the second column. So these hours per week are X values, and the number of employees is our frequency information, which we'll just denote by F. So if we want to calculate the mean and the standard deviation, well, we've done a mean calculation for group data before. Let's just refresh our memory here. We want to calculate the mean. We are going to take each of our data points. We are going to multiply it by the frequency with which it occurs, and then we are going to add them all up. So that'll give us the total number of hours worked by all of the employees. Then we want to divide that by the number of employees to get the mean. For our standard deviation, we are going to calculate our individual deviations once we have our mean, square them, and then again multiply them by the frequency with which they occur. Because for each value for the hours per week, or each X value, the deviation is going to be the same for each of those employees that works that number of hours. So we can just take the individual deviations and multiply them by the frequency, add them all up, divide by n, and take the square root to get our standard deviation. So the best way to do this is to organize the data in a table, like we've done before. So here we've got our hours, we've got our frequency, and in the next column hours, these are our X values, these are our frequency values. First thing we want to do is multiply each value of X by the frequency. So we're going to do 1 times 12 is 12, 5 times 32, 160, 35 times 7 gives us 245, 38 times 8 gives us 308, and 42 times 5 gives us 210. The total of all those frequencies times x's, let's just write it down here at the bottom, 931. Now we want to figure out the number of things that we're interested in. That's going to be the sum total of all of our frequencies. So 1 plus 5 plus 7 plus 8 plus 5 gives us 26. Now we have enough data here that we can calculate our mean. Our mean is going to be that 931, the sum of all of the frequencies times the X values, divided by our N value, 26, gives us a mean of 35.8 hours. Once we have our mean, we can start calculating our deviations in the next row of our column. So we are going to take each X value and subtract the mean from it. So for our first one here, our X value, remember, is 12. We are going to subtract off 35.8 to get negative 23.8. Our next one, we are going to do 32 minus 35.8 to get negative 3.8. And so on and so on. So I'll get negative 0.8, then I'll get 2.2, and finally 42 minus 35.8 is going to give me 6.2. I want to square each one of these deviations, so negative 23.8 squared gives me 566.44, and so on, 14.44, 0.64, 4.84, 38.44. Finally, take each one of these deviations, multiply it by the frequency with which it occurs. So our first one, our frequency is just 1, so we'll get 566.44. For our second one here, our frequency is 5, so 5 times 14.44 gives us 72.2. And we can keep doing this multiplication, 4.48, 38.72, and finally 192.2. Add up all of these items in the last column here to get the sum of all of our squared deviations times the frequency. So this would be the sum of the squares of all of our deviations, 874.04. And now let's go ahead and calculate our standard deviation. It's going to be the square root of the sum of all of the frequencies times all of our individual deviations. Clean that up a bit, deviations squared, and then we want to take the average. So divide by, in this case, the number of things. So let's put in what we've got here. We've got the square root of our 874.04 divided by 26, okay, which gives us a standard deviation of 5.8 hours.